What is this steady state probability vector? Remember your transition matrix T times some x1 vector give you lambda times. Actually, your transition matrix is T x1 to give you x2. You keep on transiting, then become x3, then become x4, then become x5. Every time you apply T in. If you can collect all these things together, it becomes T times some eigenvector equals to an eigenvalue times the same eigenvector. Steady state. After you apply T many times already, or you can put this as T to the power of n. After you do it many times, your transition from one to the next one becomes the same. It never changes already. Steady state. Once it never change, that means what? T, forget about n, T steady state equals to 1 eigenvector. It never change. It transit from one eigenvector to the same eigenvector. Okay? You understand what I'm trying to tell you? Your transition means going from one state to another state. Now the state is the same as before. Of course, your lambda must be equal to 1. Steady state. Lambda equals 1. You already found already. Two eigenvalues are lambda equal 1, lambda equal 1 minus p minus q. So, when lambda equals 1, you find what is the eigenvector? Q over p, 1. In other words, at steady state, your lambda equals 1 and your eigenvector is q over p, 1. See? How come this one don't tally with your answer in your question? Well, I told you eigenvector, you can have different values, different normalization. I multiply throughout by 1 over p plus q. I multiply by p over p plus q. I still can call this eigenvector, right? It becomes q over p plus q. Sorry. Becomes what? Q over p plus 1 over p plus q. QP, which is the answer inside the question paper. Okay, so whether it given as this form or this form, the same.
Yang sama lah. Dibalik je, dia set balik.
Can I close this question? Application. Second application. Using eigenvalues. Your A matrix now you call it T or transition matrix. What is a transition matrix? Transition means transit from one state to another state. Transition matrix means if I give you a transition matrix, it just means that now if I got x1, x2, or let's call it x1, y1. Create one particular state, x and y. Apply the transition, you will move to another state, x2, y2. If I apply the same transition matrix to this, let's call this transition matrix T, yeah? x1, y1 to become x2, y2. Now you apply the same transition matrix to x2, y2, you will go to a third state, x3, y3, and so on and so forth. Okay, this is equivalent to saying I apply the transition matrix 2 times to my original first state. Now it goes into the third state. So if I apply n number of times, t to the power n, of my original state, you will now move into a n state. Okay, transition matrix from state 1 to state 2 to state 3 and so on and so forth. Okay, now the question. Derive the general expression for the n power of the transition matrix. That means when t to the power of n, I need to find this. Because that will tell me if now my first state is this, that n state, what is my state now? n times transition, what is my state? If I can find what is t to the power of n. Okay, transition matrix. The second application for this tutorial on eigenvalues and eigenvectors. So again, before we do anything else, let's find the eigenvalues and eigenvectors
Transition
of
matrix.
this matrix
Sure.
P given by 1 minus
Okay,
P, Q, P, 1 minus Q. Alright, eigenvalues, eigenvectors. Lambda I minus A determinant equals 0. So lambda minus 1 plus P minus Q minus P, lambda minus 1 plus Q. This one must be equal to 0. In other words, lambda minus 1 plus P times lambda minus 1 plus Q minus PQ equals 0. You must find the values for lambda. How do you factorize? Notice it's lambda minus 1 minus lambda minus 1. I'm going to put this together and put this within the big bracket. Okay, treat the lambda minus 1 as one unit, then you can easier to see. Alright, it's the same, right, as before. So this times this, it becomes lambda minus 1 square plus P lambda minus 1 plus Q lambda minus 1 plus PQ minus PQ. Of course, these two are cancelled, and you have this. Factorize out the lambda minus 1, lambda minus 1 plus P plus Q equals 0. In other words, lambda equals 1 or lambda equals to 1 minus P minus Q. Two eigenvalues found. Will the second eigenvalue, or can it become the first eigenvalue? Remember, P is positive from 0 to 1. Q is also positive from 0 to 1. Can the second eigenvalue become the first eigenvalue? Yes, provided P and Q are both zeros. But the special state, P and Q will be between 0 and 1, not inclusive. So, second eigenvalue will never become the first eigenvalue. The two eigenvalues are distinct, different values. Eigenvectors will be independent. Eigenvectors independent, the model matrix P will be invertible. Model matrix P invertible, that means you have the T matrix, or the A matrix in this case, will be diagonizable. I told you already, if it's not diagonizable, can't do it. Alright, will be diagonizable. Sure. Next, find the eigenvectors. Lambda equals to 1. Eigenvector will be lambda I minus A matrix will be P minus Q minus P 1Q. This one of course become P minus Q 0 0, and this one will become your eigenvector 1 will be same time, I think it's 1 Q over P. No, the other way around. Q over P 1. Okay, go back and evaluate this. This one, P x1 minus Q x2 equals 0. Put x2 as 1, then what is x1 in terms of that 1? Okay, come out with this. Okay, second eigenvalue is lambda equals to 1 minus P minus Q. So lambda minus A, to find the eigenvector, straight away it is lambda 1 minus P minus Q, 1 minus P minus Q minus 1 plus P minus Q minus P, 1 minus P minus Q minus 1 plus Q. Cancel, 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 leaving only minus Q minus P. Cancel, 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 leaving only minus P. Of course, this one straight away it become 1 1 0 0 after ER over. And of course, this one, the second eigenvector is 1 minus 1. Question so far. This is standard procedure from tutorial 5. I'm just using tutorial 5 to find eigenvalues and eigenvectors. After a while, you get very boring. You all haven't come to the
Maths
stage yet
basic.
because you don't know how to be bored. At this time,
Maths basic.
try a few more times, you will become bored. Okay?
If I did.
Trust me. Trust me. Okay, try a few more times, you will become very standard procedure, nothing special about it. Alright? At this stage, where your eigenvalues found, you have your eigenvectors found. Once the eigenvectors found, your P matrix found.
Aku kerja tau, lima. Kat surat.
Okay? Once your P matrix found and they are independent eigenvectors, of course your P inverse A P, or in this case your P, not A, PP, will be equal to diagonal matrix. What is a diagonal matrix? Again, it is a lambda 1, lambda 2, 0, 0. And in this case, is your 1 and 1 minus P minus Q, 0, 0. This is lambda 1, this is lambda 2. Right? You must get up to this stage, everything found. Then we can talk. Okay? We can talk now. What's the question? Derive the general expression for the n power of the transition matrix T. I want T to the power n. Now, if you attack this directly, no way you can find. If n is 10, that means I multiply 10 times 2 by 2 matrices. Not possible. Right? So there must be an indirect way. Okay, in this case, your T vector x is equal to lambda vector x. Sorry. Using this, P inverse T P equals D. Look at this again. All variables, you must know what is known, what is not known. D, completely known from your eigenvalues. P, completely known from your eigenvectors. Once you know P, you can also find your P inverse, completely known. The only unknown is your T down here. Alright? Now this T, if just one T, is your question given, one T. But they want T to the power n, not just one T. They want T times T times T times T times T, n times. So how to change this now? In other words, now to make P the subject. I bring the P inverse over, it becomes TP equals to PD. Bring one more P over, it becomes P inverse. Now I make T the subject. So now, if I want T squared, it means PDP inverse times PDP inverse. Notice, your P inverse and your P become identity. D times your D, they are diagonal matrices. It becomes P D squared P inverse. Similar, right? It just means T to the power n. T times T times T times T n times will become P D to the power n P inverse. Can you find what is D to the power n? If you know what is D, you just each, because they are diagonal matrix, your diagonal values raise it to the power n, it becomes D to the power n. Your P already found, I need to find what is my P inverse. So at this juncture, my P is Q over P minus 1, 1. P inverse, wow, bring back your lecture notes. How to find inverse? What? Doing 1 over determinant times adjoint of P over P determinant. Correct? Yes. P determinant, very easy. Q over P times 1 minus 1 times 1 plus 1. So this is P plus Q over P. Correct? Yes. What is the adjoint of P? Cofactors of P transpose. Find the cofactor of this. The cofactor of this is 1. Transpose, I do it step by step first. Then cofactor of 1, Q over P. Cofactor of minus 1,
1.
but plus minus. So it's supposed to be 1 put inside here, this position here.
Become -1.
So it become minus 1. Cofactor of 1 must put in this position.
1.
It's actually minus 1, but because negative. Plus minus, negative.
1.
So supposed to be minus 1, negative again, become 1. Transpose it. 1, 1, minus 1, QP. I'm doing it step by step, if not you all get very confused. So now I got both adjoint of P and the determinant of P, I can put inside here. Determinant of P is the denominator, so I'm going to flip the determinant of P become P over P plus Q. At times the adjoint of P, which is 1, 1. I hope I get it right, if not we will do everything again. Correct, wrong? Agree, disagree? I can be wrong, please. I'm human. So please let me know if I'm wrong. Okay? Just step by step, very methodical, nothing special, except that maybe it is you need to know a lot of things to put everything together. Any more? So now I just need to put P multiplied by D to the power N, P inverse. I got all the ingredients already. So my T to the power N is P D to the power N, P inverse. What is P? Q over P minus 1, 1, 1. What is D? First eigenvalue is 1, 0, 0. Second eigenvalue 1 minus P minus Q. Let's call it lambda 2. Raise it to the power N. What is P inverse? P over P plus Q. This is a constant which I can shift anywhere I want outside the matrices. Alright, multiply by the 2 by 2 matrix 1, 1 minus 1 Q over P. Then algebraic manipulation, bring the constant outside, all the way outside. The first one, we can leave it first. Second one, this n I can bring in 1 to the power n is 1, lambda 2 to the power n. Correct? Diagonal matrix multiply is still the diagonal matrix. So now I'm going to multiply in the matrices. This is 1, 1. 0, 1, 0, 1, 1, 0, 1, 0, minus 1, 0, Q over P, lambda 2 to the power n. Just do it step by step. I hope I'm correct, not to do anything. P over P plus Q. Again multiply Q over P minus this. Minus, minus become positive. Correct? This plus this. Alright? This plus this. So it's Q over P minus Q over P lambda 2 to the power n. This plus this. This plus this. 1 minus lambda 2 to the power n. This plus this, 1 plus Q over P lambda 2 to the power n. Okay? The answer, is it correct?
Yes.
Yep. You factorize, you get the answer. A bit tedious,
Times C na.
but just very step by step. A bit tedious.
Tiba bisa ni. Lagi sama bisa.
Yes.
Solution, right? The last
Argument
part,
tu.
when they say 1
Satu
over P
kita
plus
ni.
Q, what
panjang. Maybe yang first try to toilet.
Haven't come to the
Macam
point yet.
balik habis.
You are saying what?
You give the solution is where you get this
Kena
answer.
tengok pasal
Huh?
apa.
You say where Langa is listing, okay, understand what is this